How are you? Good to see you. You're muted. I can't hear you just yet. For now, I still can't hear you. Can you hear me?
Well, this is Hank. I can hear you. Hi.
Hank, hi.
Hi.
I'm
I'm on
Nathaniel.
vacation actually, so I'm visiting.
Okay. Well, thank you for joining. Yeah, let's just give people a couple more minutes. Um, you and then we'll start.
Yeah. Hi, Nathaniel. Is your mic working, or is? Oh no, he left. Okay, so he had connectivity issues, I assume. Okay.
Well, maybe he'll be back. Who knows? One can
Yeah.
hope. How are
I'm
you,
here for the
Hank?
logistics. Oh, I'm drop dead tired. I've been.
Yeah.
It's a kids' vacation, which is translation to not a vacation at all. Yeah, but you get a new clear mindset because you are exhausted to the bone.
Yeah, I hear you. Okay. So I
Yeah,
shared
I'm
my
here for the
screen.
logistics. Exactly. There's an interim. We have to prepare stuff for an interim. I think
Yes,
that's the target, and yeah, that's why I'm here
correct.
to not miss the tasks and the things and such.
Right. So when has the intro meeting been scheduled?
No, I don't know. I know nothing.
I haven't seen. Okay, let's see.
Okay.
Let's see if
Michael will be joining in 6 minutes. He says MCR. I just got a message from him.
oh good. Okay, good.
I will tell
So
him that you will be delighted. Mark will be delighted.
I will be delighted. Okay. So the meetings, let's see. There's no, see there are interim meetings scheduled for February, but there is no meeting scheduled yet for September. So we don't know what's going on yet.
Yeah, I'm dealing with a new email inbox and it is unfiltered. So now I have to filter manually all the time. It's hassle and it's so many,
Right.
many emails. Jesus Christ. Okay. No, there doesn't seem to be a share email. I see one from Deb, but that one is separate. Nathaniel was active, so posting, blah, blah, blah.
Hmm.
Yeah, okay. So this is a confidential computer. Okay. Yeah, we are basically have we can might have a little bit of time because I think there's a minimum time to announce the interim, which I think is 3 weeks. You cannot
Okay.
have an interim without a minimum announcement time of 3 weeks. So we have at least every day from now 3 weeks.
Okay, good. Well, that's good. We'll need it. So, let me update you on something I've been working on that is, you know, has bearing on the intro meeting, because of, like what there is like a work now started on a proof of concept. And first, I want to walk you through this. What I'm observing is we have lots of different mechanisms by which different workloads can obtain credentials. So far I've counted four. There may be others. So there's Spire. There is
Yeah.
EST, right? So enrollment over
Mhm.
secure transport. That's RFC
Yes.
7030. That's the one that
Yes.
Mike
Yes.
brought
Well
it to the
known.
attention. There is Acme V2. And there is
Mm.
another one that I just found yesterday when I was looking into Envoy. So you know what Envoy is, right? It's a sidecar
Yes.
that does TLS for workload. Well, it has a, I think it's like called RST or something like this. What is it called? No, that's Acme. But anyway, I was looking through it, and it's an Envoy API that Spire also supports. That has its own protobuf definition, and
Oh, jeez.
it basically is the thing that fetches certificates
Yeah.
for Envoy specifically. And none of them will work for confidential workloads because none of them really support the notion of remote attestation, multi-hop things involving freshness, supporting evidence. None of that doesn't do it. Now, I do believe that it's possible to extend all of these protocols. Like it's not possible to reuse them, but it is possible to extend them. So I formulated a set of requirements and I'm proposing an architecture and I'm doing a POC around it. And I solicit any and all help that you guys can provide, advice, review, code contributions, whatever it is. There's now a GitHub repo where this POC is going to live. And I am basically, all the time I can spare. I'm now figuring it out. But let's talk about the requirements. So for one, it needs to support minting new and retrieving pre-existing credentials, right? So we talked about replica workloads, which means that a bunch of workloads share the exact same credential and key, or there are other situations where a workload might want to go fetch its own credential. The interesting part is when the workload starts up, it may not know because like the workload is at the behest of the environment where it gets deployed. So my idea is, imagine this: you develop a workload, and you want this workload to be able to be used pretty much anywhere in the world. And you don't know if it's going to be dumped into an EST environment, a Spire environment, an Acme environment, like you literally don't know. So
So,
what you so again, so follow with my dream here, right? Now we can talk about if it's good or bad. All right. So now the credential formats are X509 certificates, Whimsy Wix, which are identity certificates, Whimsy WITs, which are identity tokens, bearer tokens, pre-shared keys, and I'm basically being ambitious here. Any future format through architecture extensibility. So in the architecture, there has to be a possibility of getting new certificates or new credentials of any type. I started out, if you remember, we started out talking about, well, we'll only use proof of possession credentials because, we're fancy like that. And, what good is confidential computing if you can steal the credits bearer tokens? Well, the world is full of bearer tokens. So, I'm like, I've given up. Like, okay, fine, we'll support.
no, no, no.
Right.
Before you continue, there's another option here that is indirect. It stems from individual TPMs
Yeah,
that can be, and then you have the DAA grouped key.
right.
That is a replica option, right? So
Hmm.
every replica could have a could exercise the dance of the join protocol for DAA. There
Yeah.
is an implementation for TPM2, which is the most important thing because DAA was initially
Yes.
created for 1.2 and is pretty
Yes.
useless. But there is the Huawei did some stuff, and Thenesis from TCG did some stuff, and so it's basically done.
Hi, Michael.
Um, yeah, so that's why I
Okay.
wanted to bring at least the
So
DAA for TPM2
please,
on the list
please
for
bring it in.
replica.
Look, let me put the link of this document in the chat.
Okay, I
As
will edit
usual,
it.
put all the evidence, dump everything in here.
Sure, sure.
We'll incorporate the problem trying to solve here. Michael, I'm going to bring you up to speed in a second on what we're up to here. The problem, of course, is that
Thanks.
this is the unified model. Feel free to request access if you don't already have access to the folder. I'll grant it right away in my other window here. What I was going to say is the problem, of course, is you're at the mercy of the relying party. If the relying party wants a JSON Web Token, you got to give it JSON Web Token. Now, you can maybe do something along the lines of the confidential workload, is fancy like that and procures its own credential, and maybe there is like some middleware that converts it into a bearer token. But it's whatever the relying party wants, the relying party is going to get. All right. So the other thing that is kind of important here is minimal. By the way, so Michael, this is your original idea of extending EST, but on steroids. Okay. The idea is not just EST, but Spire, Acme V2, whatever else that the workload may, be asked to use to procure credentials. We should be supporting it all. And I already see a share request, so let me grant that
Yeah,
real
I will
quick.
add also send another one. There's yet another one in your
Yeah.
inbox now.
Now, okay. So here we go. Michael, you're in. Let me see if I get another one. Yeah. Hi,
Yeah,
HB.
yeah, that's
HB.
me.
You're so fancy. Okay. All right. So Okay. So then the minimal trust boundary expansion. What I mean by this, I don't want to pull the entire Spire agent into every workload. I want to make sure that the workload, like, it's not possible to do it with zero additional code, but I want to make sure that, any, uh, any additions are as minimal as can be. Then we're talking about the following credential acquisition mechanisms. So for POC, I'm hoping to hit EST and Spire, but in the future, maybe Acme V2. And is this a credential format, or is this a credential acquisition mechanism? Because if it's
It's
an
a
acquisition,
credential. So you have a credential format, which is CPMA cert. It's a credential you start with, and then you do the join, which is
yeah.
a dance. This is a protocol,
I'm
and then
just
you get
saying
the
we have two lists.
yeah.
We have lists of credential formats like JWTs and WITs and WICs and certificates. And below here, we have the credential acquisition mechanisms by which the workload comes into the
Okay.
possession of a
Then I
credential.
will put
So you
it in
probably want to move it
pulse.
down
Sorry.
here. Okay. All right. So then the other thing is a workload may have to talk to different backends. And it could even be that the workload needs to invoke different credential acquisition mechanisms per target, right? So it may be, I'm using JWTs for this database and I'm using a WIT for this backend, whatever. And it could be the same workload, but, literally who knows? So there should not be an architectural limitation that you're stuck with just one way of obtaining credentials. Uh, Also, whether you are end up using passport or background check model, from the point of view of the workload, it doesn't matter. It shouldn't matter. And finally, we cannot assume that the workload, and this is Nitro. This is the Nitro case. The Nitro enclaves do not have network or storage access. They can be invoked by some hosting environment, but they are, really, uh, not very powerful. You cannot like stick an HTTP client in there. It's not going to be able to just independently have its own access to the outside world. So we cannot assume that. So therefore, a mechanism called Credential Acquisition API or CAPI is defined that I'm going to explain in a minute. It's not complicated API, and this is the minimal trust boundary expansion. So long as your workload contains the CAPI client stub, it should be able to do all the things that I'm talking about. So here's the general architecture is this. The workload runs inside of a trust execution environment, some kind of trust boundary, and has a CAPI client. In the middle, it's one box, but it's really a client server system that I call the credential acquisition system. So this can have a client side of Spire agent and a server side of Spire server, or it could be EST client in the client, and it could be DST server as a server. But the client part of the credential acquisition system is the server of the CAPI API, right? And it's outside the workload's trust boundary. It's not fully trusted by the workload. This is where stuff lives that helps you acquire credentials, but doesn't really get to see your secret. And it's the credential acquisition system that talks to your identity provider, CA, your RATS verifier, or your key credential store, whatever that is. Like the workload itself does not talk to the verifier, does not talk to the CA, only talks to the CAPI server. All right. So let me then show you. I'm probably have to go zoom in for this. And I hope after this conversation you're as excited about it as I am, because I really think this has legs and can work. And tell me if it can't. All right. So let's see. So here's the idea. There are four different setups here. And all of these, this is no longer the workload, right? So the picture starts with the everything excluding the workload. So it's the credential acquisition system and the stuff on the right. So on the left two are ESC, the right two are Spire, and I put them side by side so you can visually appreciate just how similar these things are. The left two are uh, so this one would be the minting of new credentials. So here it's EST, and that EST uses a certificate authority. And the second one is a replica case where a workload goes and obtains a credential that already pre-exists, right? Whether it's background or passport doesn't really matter, but your EST client is the client side of the credential acquisition system and is the CAPI server. And then your server side of the credential acquisition system is the EST. All right. This is all the same, but your client is not the EST client, but the Spire agent, and your server is not the EST server, but the Spire server. Now, you know that the workload API doesn't really support this, so we'll need to go change a few things, change the on-the-wire format. But here's the idea. The workload says, okay, I'd like to obtain credentials. So maybe first it asks for freshness and then it supplies some evidence and maybe it wraps some keys and provides CSRs. And all of that is the CAPI, the credential acquisition API. And it's the job of the credential acquisition system to take these requests and convert them into EST requests or Spire requests or Acme requests or whatever else may be out there. Okay, are you with me so far?
It's yeah, straightforward
All right,
Yeah, it's
awesome.
far as I
pretty.
go.
Yeah,
So
but
then,
the simplification of the boxes might be a little bit oversimplified, but I see your point.
yeah. So what I created then is, uh, and I can add anyone who wants this, but I created this GitHub organization because it's a collection of projects called Try Unified Model. So again, I can add your email your GitHub handle to this. So let me stick this in the
Yeah, yeah,
chat.
makes sense.
Right, and let me explain what I put in there. I put in there, so I filtered basically by what are good open source implementations of the bits that I need. And I filtered further by everything that's written in Go, because I just wanted the whole thing to be done in one language. So it's not right. So this is the last part of this. So there is an EST passport or background check. Uh, and there is going to be effectively like I will write some sort of a hello world app on the client. That's just an HTTP client. There's going to be an HTTP server. And EST implementation is going to be the global sign, just because they have a really nice Go library for experimenting. Spire, of course, the agent and the server are written in Go. For CA, it's the step CA, so it's from small step. HashiCorp Vault for the key store. Verizon as the RATS verifier. Right, so uh, all of these have been forked and are now part of this TWI unified model. So go here for a second. So this is I'm just borrowing the TWI logo from the consortium. And yeah, you can basically see all of these repositories are over here. So I fork them all so we can play with them at will. And TWI this is specifically the stuff that is not part of any of these other repositories. So there is now a protobuf definition that you can read. And also I created mermaid diagrams that I can show you, right? So basically, here you go. It explains how all of these exchanges are
I don't
supposed to
think you
work.
made the Twium repo public.
I don't, I have not, but
Okay.
I
So
can
it's
add
you
you,
have
hold
to
on.
you'll have to enjoy to join us. You'll have to invite us directly because we can't ask.
Okay, well let me do that right now because I would love for you to be able to see what's in there. So how do I do this, people? Um, invite member.
Add us to well, maybe you can add us to the organization.
Yeah, that's what I'm trying to do.
Yeah.
Yeah. Do you want me? put me like GitHub handle or something I can put in here.
Put MCR.
That's you. All right. Wait. Come on. Wakey, wakey. Okay. So, Hank, how do I add
It's
you?
my first name and my last name, all low, non-capitalized, one word. Hank Burkhart's one word. That's my GitHub username.
Yep.
I'm in the fortunate position of having a unique identifier on the web.
Right. Awesome. And
And
Nathaniel?
is uh telephonic T-E-L-O phone
Telephone phonic.
yeah, telephonic. Or is it, what is my, I have so many different ways of saying this thing. Can you just type in Nathaniel Ritz? Will that work?
I would assume that your actual name is more unique than what you
There it
Telephonic
typed.
is. There we are.
Yeah,
robotics. There you go. Okay, cool. All right. So now you're all
wonderful.
invited. So please feel free to contribute in whatever, capacity way you can. And again, as I said, let's go back to repositories. Go to TYUM. I really love modern tooling.
Do
Like
we
I
have
can.
to agree on joining an org, or I'm not entirely sure if that's a request email. I know that being collaborator on an individual repo requires
I think
confirmation.
that adds us at least we can see all the repos. I think it adds us to the, or it
No,
makes it
Yeah,
you're all
easier to
members. You
add us
can
to
do
all the
whatever.
individual
yeah.
things.
So I don't get an email. I think with orgs you don't get an email. That's
I
why I
got
was.
I don't know if I got an email, but I definitely there was an invitation I had to acknowledge.
It's got me.
Oh, that is an email.
Okay.
I,
So
I
you
think I
okay.
just logged into the right place and that it showed it to me on the website, not. But there's probably an email.
Oh, I see. Thank you.
If you're logged in under GitHub and you go to this organization, I'm sure it will let you in.
Sure. And if I would know what email is my GitHub email, then I would know. Thank you. I will figure that out.
All right. So I created three mermaids. This is how you initiate. So basically, there are two commands that you have to issue one after another. The first one is called initiate. And initiate, and by the way, feel free to critique it. That's probably not the final form of it. Initiate is when you basically ask for freshness, ask for the nuance, and you basically say, okay, I'm ready to obtain a credential. And the second one is either mint or retrieve. So mint is you're saying, I would like to get a new credential, and retrieve as I'd like to get an existing credential. And if you click on any one of these, it basically shows the proposed flow from the workload through the CAPI client to the CAPI server to the credential acquisition system client to credential acquisition server to verify and whatnot. So basically shows you the entire progression. Same for Mint, where in this case there's also a CA, certificate authority, identity provider, and retrieve, where something's already been created. This is all in line with the kinds of things we already discussed in this working group. But
So you want
validate,
us to
please
use
verify my work. It's all in here.
version Golang 1.2?
Sorry.
Current is like 1.24.
Golang, it's like 1 to 2. I think I'm using 1 to 6.
Okay.
So if you go to README,
Yeah, it says 1.2 and I'm like, oh wait, that's really old.
where does it say that? Oh,
There.
no, I need to change that. It's like
All right. Okay.
1.26.
I happen to not be installing on a Debian machine, so on an Ubuntu machine, so
Yeah.
it
I
doesn't
think
have
I think the
doesn't have adapt repository, which is normal, but
No, so this
anyway,
one,
I have it's fine because I
the
have a
protobuf
newest enough
compiler,
version of the
the
compiler.
default one that on Ubuntu was not working for me, so I ended up having to do this.
Yeah. Okay.
Okay, so that's yeah. So I needed that. But anyway, so there is a now protobuf definition, and I'm also adding a very simple. So the idea is this is what I would hope the PIC would accomplish. There is a workload. It's an HTTP client. It wakes up. It has no credentials. It doesn't know how to authenticate to anything. And then it will use the SCAPI API to get two things. It's going to get a TLS. Sorry, it's going to get a TLS certificate, so it can do MTLS. And then it's going to use it again and get an application level, maybe a JOT or workload identity token. And then it's going to go to HTTP server and establish a TLS connection, authenticate with mutual TLS, and then it's going to uh, further do application level authentication to the server, just to show that we can do both. Right, so that's the current idea, and then the HTTP server is sitting there and basically waiting to authenticate the client, and then inside we'll be able to experiment with different methods like EST extensions and Spire extensions and all of that business. So okay, any questions so far? I've been talking a lot.
Oh, that's fine. Makes
I'm
sense.
enjoying the info dump.
Yeah, but protobuf is hell, so I hope we can, kind of, I don't know, work with that.
It's actually not that. I mean, I find it to be fairly easy to work with, and it compiles into Go, and you can start doing our gRPC with it.
Yeah, it has the same issues as JSON schema. So
Yeah.
inherit their own problem space. So you can do a lot of specifications and protobuf that are different, creating the same messages, thereby being interoperable. That is a huge hassle in large-scale implementations.
Well, so Spire uses it to obtain certificates. So I was hoping that there is going to be enough there. Also, Verizon uses it,
The
right?
problem with
Go.
protobuf is that
Yeah.
both ends are expected to run the same version of the code
Mhm.
without negotiation.
Yeah, it's
So it
managed.
it is not, if I upgrade my end, even though I'm a completely superset of what you have on your older version, we're not compatible.
Exactly.
Okay,
And you
and
never
that
know.
works just fine.
Works
That works
forever.
just fine
Yeah.
for Google's environment where they lockstep upgrade, but does not work in an internet environment where not everyone upgrades on the same day of the week.
So how does Spire then work? It uses protobuf.
I don't know that it
Pure
can.
chance.
Verizon uses protobuf.
Verizon
is
opting
trying
out.
not to.
Yes, exactly. It's trying not to. That is a red herring. It definitely is not trying not to.
So protobuf, basically what protobuf does very well is it maps a specific structure into a wire and back again, but doesn't do it in a way that is where the version information for the structure is present. That's one of the major reasons why CBOR is not just protobuf, and it could have been, but it's not.
Deliberately is not, because that is the reason. Because JSON schema is the problem that you have. This is even worse than protobuf, because you can have various schemas creating a valid message for your current setup, and everything works fine. Although you're already not interoperable, but you don't notice. And then suddenly your JSON schema changes, and one side can't validate the message of the other side suddenly, and nobody knows why, because there are more than one way to express the same message, and that is a schema, JSON schema inherent design. I want to say feature, but I assume it's unfortunately a bug. So protobuf has the version problem. It's not negotiable, which is fine. But I think protobuf got one thing right. Versioning is not your problem. Separate versioning from enrollment. Great. I think that's an excellent idea, but people can't do it. People do not understand the concept of versioning being outside your namespace, so to speak. So that is like baffling to people who were tainted by XML for 20, 30 years. They expect the namespace to include a version. Protobuf doesn't do that. And that is right. That's the right way to do it. But on the other hand, they have a gazillion microstep versions that are not interoperable. So all these things are convenience things because they both, the authorization schema as protobuf, can do code generation from schema to code, which is excellent. CDDL can't do that. It is just too arbitrary, right? Because you don't know what's an input message, what's an output message. It's just a message description language. It can't do with its current scope do code generation. We are working on that, but it's taking its time and it's not there. So everybody loves JSON schema because it can do the web human UI, it can do the code generation, and can do the messages. But it is really, really dangerous, and people are sick and tired of it. So it is phased out of hyperscalers deployments. I don't want to name the Azure owner right now, but they phase it out because it is just too much cost. It's just too much cost long term. So now you have Protobuf. Protobuf has, again, a smaller attack surface, to speak, a smaller failure surface. But it is, as MCR highlighted, you never know. You never know when it will break. And that is an antithesis to open ecosystems. You can, if you have a strong version control in your authority domain, trust domain, and so forth, it works very well. But if you want to do this across the internet, it does not. As simple as that.
Okay. Well, I mean, is there at least a hope that this can be a simple enough API that can gel and sit there and not have to, version it too often? And then, once in a while you can say.
You have to specify that outside the ITF in any case, because you can't specify protobuf APIs in the ITF because they're unstable and not standard. And for good reason. That might change for JSON schema. They just started the JSON schema working group, and it will take about approximately 5 to 7 years to fix that. So
really think that long? Okay, well, all right. Yeah, I just for fun, you may, if you ever sit down and look at XDR, which was from Sun from the 1980s and NFS. Yeah. It's actually RFC 4506. And you got to wonder, and what the brilliant part is that every function that encodes is also a function that decodes. And it's really kind of cool that way, but it also has no versioning unless you build versioning. Yeah, unless you start every structure with a version structure, which NFS did, but it also didn't have a language that really explained.
Yeah, so we'll be really, really careful with the convenience community projects here. And I would deem both.
By the way, notice that I'm not doing protobuf over the internet. You did catch that, right?
Yeah, I get that.
It's
but
not.
You
it's not. It's.
I'm not. None of the protobuf stuff hits the wire. This is all between the workload that learns locally and its CAPI server, which is basically on the same box. And the job of the CAPI server, which is then the EST client or the Spire agent, to convert that into the whatever on the wire format, EST, Spire, Acme, whatever.
Fair enough. Yeah. Fair enough. But
not the same.
Your workloads and your host are now locked in a version thing, and you better not deploy workloads with different versions on the same.
Yeah, I think that's going to be okay.
No, but you assume these are the same authority, and under the same authority, there's no negotiation that works.
Yeah,
it still puts a real hassle on the manager of the server because they can't incrementally upgrade. They have to forklift upgrade the whole server.
But and probably the whole ecosystem.
Again, which server are you now talking about? So the CAPI server is your EST client.
The physical server, or whether it's virtualized or not, that has this spiffy Spire agent, I think you said, and Spire server.
Yeah. So the agent is on the same box as the workload, typically, right? Because
I understand that, but But what I'm trying to say is, does that agent serve multiple workloads?
Notice that Spire already works this way. There is Workload API that is
Yeah,
protobuf.
I'm not arguing at that point. What I'm trying to say is that if that workload, if the same box runs multiple workloads, then you have the problem that you cannot upgrade the spiffy. I think that's right. We're talking about, right? You cannot upgrade this the spiffy version of any workload until all workloads are ready to upgrade. Again,
Well,
that doesn't
I,
bother Google because
yeah,
they never upgrade a physical box that
yeah,
way,
yeah,
right? They install a new one, wipe the old ones, recycle them. It always has a consistent thing. That's why in Go, they always compile everything to, they don't include it. It's all statically linked, right? They solve
yeah.
all of their, as what used to be called DLL hell, by not. Go does not really do DLL, do shared
Hmm.
libraries. You just build
Hmm.
everything into one executable and you ship that. And it
Okay.
doesn't matter that it's,
Well,
17 gigabytes, because that's the only thing that's the only code that's going to run on the server anyway.
right. Well, again, uh, i- my guess was if it works for Spire, and it works for Envoy with its RST, right, which is the credential, like
Yeah.
whatever requisition thing, then it'll probably work here. And this doesn't have to be standardized through ATF. What gets standardized through
Okay. I
ATF are EST extensions, and then with the
yeah.
Spire working group,
Let's.
it's the Spire extension.
I think that Spire will evolve, but I agree with Hank. Well, I don't know that. I don't know why. I don't think it's attached to Jason path, but it doesn't matter anyway. Continue. We're mostly just aware of the difficulties in trying to standardize certain things and why there's certain decisions.
Yeah.
Right.
To
Why the
keep this out
ITF
of scope.
didn't just adopt protobuf, which would have made a lot of sense and would have been way easier 10 years ago than CBOR in terms of mind share, but it just wasn't possible.
Yeah. Well, again, the CBOR is the on-the-wire encoding that would be something that the EST client generates and the EST server needs to understand. And it may need to go through protobuf as well, because I mean the client needs to obtain like evidence, right? Needs to generate evidence, and it needs to somehow communicate this evidence all the way back to the RATS verifier. Right through all of these intermediate encodings. But I think I still think that this architecture allows us this really cool pluggability that we can literally take any any protocol, EST, Spire, Acme, go down the line, add to them the necessary extensions. So say, so it's a two-step. Get me the freshness, and then here's my evidence with some embedded keys, and then give me back my credential. Right? If we standardize that and we show how it can be done with EST and Spire, I think that can actually give us the critical math and snowball into where pretty much any workload can implement this API, do these extensions, and now every workload in the world has identity that's remotely attested. Okay, that's my dream. I'm hoping to convince others to follow it.
Okay, I have to prep for another meeting in 5 minutes.
Okay, well, I'm glad you gave this a hearing. So going back to what needs to happen for the interim meeting, well, it needs to get scheduled. We should probably propose EST protocol extensions, right?
Yeah.
And this POC, I'm just going to be working on it as fast as I can. Any contributions, of course, are welcome. You now have access to all the code. So I think probably the next good thing to do is for next meeting, let's talk about what actually EST messages look like.
Sure.
Like
Sounds good to
precisely.
me. Sounds good to me.
And separately, we can talk to Spire about revving their workload API for what we need to do.
Okay,
Yeah.
I gotta go. Thank you very much.
All right.
Have a good
Hank,
week.
Nathaniel, any parting words? Anything else we need to discuss today?
No, thank
I've
you
just
for
been a
your.
sponge today, so
All right. Good. Then I will see you all next week.
Yeah, I'm still on vacation next week. I know it's a very bad European habit to have long vacations, but I will try to join.
Well, it's the most European thing ever, so enjoy.
True.
All
Bye-bye.
right.
take care.
Talk to you soon. Bye-bye.